All right, so it's 12 o'clock, and so welcome everyone. I'm going to go ahead and do an introduction here, and we'll get started. Welcome to the Rose Seminar Series. Today we're fortunate to have Dr. Grant Gardner, who is an associate professor from Middle Tennessee State University, and at that university, he's a faculty for what's called the Mathematics and Science Education PhD program. And so why is it important to mention this? I bring this up because that program, the MSc program, is actually one of the top tier programs producing science education researchers that actually a lot of us are all utilizing right now in the time of COVID as we move towards more evidence-based teaching and actually moving online. Grant is also an amazing father and husband. He's also an athlete who tears it up on the Ultimate Frisbee tournaments series. And he's also someone I fortunate to call a good friend and a mentor. What I want to say at this point is right before Grant starts, please put any questions you have in the chat box, and then I will moderate those at the end. So we're grateful to have him. Welcome, Grant Gardner.
Thank you. Thank you so much. This is actually the first seminar talk that I'm giving over Zoom. So I'm trying a few new things. One, I've got notes here that I'm gonna try to follow, which I usually go by more off the cuff when I talk, but I'll try not to look like I'm reading too much. But I appreciate getting a chance to speak with you all today. And what I wanted to sort of start doing at the beginning of this talk is talk a little bit about my academic journey. And the reason I wanted to do that is because for most DBER scholars, which are discipline-based education research scholars, my research has been strongly influenced by my experiences in academia. And so I started as an undergrad in biology at Vanderbilt University and went on to pursue my master's at NC State, also in biology. And what I noticed during that time was that I often found myself exhausted at the end of the day from spending time in my lab, but was always very excited and curious about the interactions I had in my classroom as I served as a graduate teaching assistant. And so I took a job as a community college instructor after that, teaching biology, and began to engage with education research as one of my colleagues got me plugged into the field, and later went on to pursue my PhD in science education research. What I hope to communicate to you today is sort of how my academic journey has come somewhat full circle, in that my current research focuses on assisting graduate students to become more effective instructors, and with the goal to increase the use of evidence-based instructional practices in undergraduate STEM classrooms. Okay. And so today I'd like to share some of that research that we've done in the field and just kind of give you a wide landscape of some of the work we've done related to this. I always like to start with sort of thanking the folks who have contributed to the data in this talk. There's a myriad of individuals, and I've worked with many more, including Penny Carroll, who's hosting this, but I do want to show you the folks who have contributed to data or research related to what I'm going to show you today. The top group here are faculty I've worked with. Elizabeth Schuessler is at UT Knoxville. Gilly Marbach-Odd is at Maryland. Judy Ridgway is at Ohio State, and Chris Miller is at Georgia. And all of these fine individuals are co-PIs with me on our NSF-sponsored BioTap grant that I'll talk about a little bit later in this presentation. Evelyn Brown is at North Carolina State University and has also collaborated in collecting some of this data. Miranda Chen is a graduate student of Elizabeth Schuessler's at UTK. And then Zach Grimes is one of my current graduate students, and Josh Reed and Jennifer Parrish are two of my former graduate students. Gina Bashara is an undergrad who has worked with me on a lot of these projects as well. All right, so I'd like to give you a little bit of an outline of my talk. I will be organizing it into three major sections. First, I would like to sort of frame the problem for you by sharing some recent data about the types of instructional practices currently being used in post-secondary STEM classrooms in the United States. I will follow that up with a discussion of what the research demonstrates as most effective instructional practices. And then finally, I'd like to spend sort of the end of my talk discussing how our research and our research team tackles some of the systemic issues of low use of evidence-based practices in post-secondary STEM classrooms, specifically through exploring the landscape of STEM graduate student teaching professional development. So part one, I hope to get at the answer to this initial question. So I'm going to organize the three parts of this talk as sort of questions. So what type of instruction is currently being used in post-secondary STEM classrooms in the United States? And I'd like to start exploring the answer to this question by showing an image. And I have to fully admit that I stole this image and this little intro from Mary Pat Winderoth. If any of you know her, she was the one who started the Society for the Advancement of Biology Education Research and presented this image at a 2017 keynote talk at the Association for Biology Teachers. But I just loved it so much that, I stole it. And I think it makes a really good point. So this is a painting of a medieval lecture by, and I'm going to butcher the name, it's Henricus de Almania, and it was painted around 1350. And what it is showing is a typical university classroom at that time. And so let's notice what these students are doing in this classroom, all right? So we have the instructor up front talking to the students, all right? We've got this front row of students all very carefully and closely paying attention to what the instructor is saying. We got the folks in the back talking, not really paying attention to the instructor at all. We've got someone in the back staring at their crotch, which to me usually indicates in my classrooms that they're texting. Now this is the whatever medieval version of texting is. And then finally we have someone here on the end of the bench falling asleep. Okay, and so this is what a classroom might have looked like in the 1350s. Now, here's a modern classroom. This is in fact my classroom. I will say that I coerced some of my introductory biology students into recreating this photo for me. So these are some of my students in introductory biology. And I want you to notice what's going on in sort of a typical STEM classroom in the late century here. So here, look, we have an instructor talking at the students standing behind the podium. The front row is all deeply engaged and enraptured in what that instructor is saying. The folks in the back are not paying attention, they're talking. There's people really texting. And of course, there's someone sleeping in the middle of the talk. And so, although this is anecdotal and although this is staged, I use this to sort of make a point that not much has changed in undergraduate STEM classrooms over the last 700 years or so. Okay? They really do largely look the same. Now, of course, this is just anecdote. So do we have data to support this claim that really, there's not a lot of change in what classrooms, STEM classrooms look like? And we do. This is data from a nationally representative survey of over 4,000 higher education instructors who self-reported their instructional methods in the United States, and this was in 2004. So faculty were asked to rate what percentage of a typical classroom time they were using extensive lecturing in all or most of their courses. And in this image, I have biology highlighted only because that's the field that I work in. But you can see the general trends for most STEM fields indicate that somewhere between 70 and 80% of class time is spent lecturing to students. Now, so this is data from 2004, so you might ask, with the advent of rigorous discipline-based education research, have we seen any trends shift? And so I'm going to change the slide now. Now see if you can notice any differences when I shift the slide. The change is very subtle. And the point I want to make is there really hasn't been much of a change. This is data from the same survey in 2014. And you will note that there's not much of a transition. Most, again, about 70 to 80% of faculty in 2014 reported that they were primarily using lecture in all or most of their courses. Now, of course, I do want to point out that this data does have some limitations. This is self-report data, and so it is possible that it's not capturing sort of the real events going on in the classroom. And also, I think this data is somewhat limiting in that just reporting how much time you lecture does not necessarily capture the subtlety of what actually may be going on during class time. Okay, so obviously lecture can have multiple meanings. And so to address some of these challenges, there was another recent study that came out by a group currently at the University of Virginia, Marilyn Staines. And she conducted classroom observations of over 500 STEM faculty using what is known as the Classroom Observation Protocol for Undergraduate STEM, or the COPUS. This is a validated and reliable instrument that collects both student and instructor behaviors in classrooms at 2-minute intervals. For those of you all that have done actual animal behavior research, this is very similar to sort of an ethology observation protocol. And so from this data, the Staines group was able to classify STEM faculty into sort of 7 general clusters based on what their own behaviors were and what their students' behaviors were. And so I want to show you some of this data that gets at the problems with self-report and lack of subtlety in this data I just showed you. So let me orient you to this data set just a little bit, because there is a lot going on here. Can you guys see if I wave my pointer? Okay, Penny's giving me a nod. All right. So on the left, you'll see sort of a code key. And what this code key indicates, the red sort of color indicates student behaviors. And sort of the paler blue colors indicate faculty behaviors, such as the teacher asking a question or the teacher lecturing, whereas the student might be, working on a worksheet in a group, or the student might be asking a question. All right. And so each of these figures I'm going to show you indicates the percentage of 2-minute intervals spent on each of these behaviors across the classrooms that were sampled. And so these are the first 2 clusters that were classified by the researchers as didactic, which largely means sort of lecture-based instruction. And I would like to first note that about 55%, or just over half of the sample that were observed, tended to lean on lecture instruction. Okay? You'll notice that these 2 clusters largely consist of sort of the instructor lecturing, in this case, lecturing with students, with just an occasional interaction by students. Very occasionally, students sort of chiming in, maybe asking a question, or maybe the faculty member asking a clicker question. Clusters 3 and 4, which included approximately a quarter of the sample, were classified by the researchers as interactive lecture. These instructors still exhibited sort of high ranges of lecture behavior in their classroom with more variability, and also somewhat of an increase in the proportion of time that students were doing group work, working on worksheets, or answering some type of clicker question. And then finally, the last 3 clusters, which was about 80% of the observed courses, were classified as student-centered. And again, this is much more highly variable in the distribution of faculty and student behavior. And what I wanted to do was just sort of use this data to answer some previous questions, but also to set up a definition here. Because those of you all who are not as familiar with education research and the type of terminology we use, I'm going to throw a few slides at you that what I call are sort of definition slides. So I'm going to hit a definition slide over the head. We just use the term student-centered classrooms. And I'll make sure that we are all on the same page. All right. The way I'm going to use this term student-centered classrooms, you may have heard this, is a learning environment in which the student is positioned as the focus of the learning. Students are seen as active constructors of their knowledge. And the instructor is positioned as the facilitator of student knowledge construction, with the students often doing more than just sitting and listening in the classroom. And student-centered classrooms are often contrasted with what we call instructor-centered classroom, in which the instructor is often the sort of focal, quote-unquote, sage on the stage, who is often conceptualized as sort of pouring knowledge into the students as they serve as empty vessels. Okay? So I do want to wrap this section up by showing one more bit of data from Staines' research. And this is just to address some critiques folks might have about the data we saw before, which is obviously you might challenge some of the data we saw before, that there's an impact of the context upon instructional styles. And the researchers did look at instructional context, including class size, classroom layout, course levels, and STEM disciplines. There were really only 2 major statistical relationships that fell out, in that large classes were tended to be slightly more likely to be didactic than predicted by chance, and that classrooms with flexible seating were slightly less likely to be didactic than predicted by chance. And then also there were various variations in instructional styles by discipline. So for those of you all that are here from different disciplines might be interested to know that from their research, mathematics and geology were seen to have more student-centered instruction than expected by chance. Biology had more interactive lecture style than expected by chance. And chemistry had more didactic style than expected by chance. And one of the conclusions researchers made from this data was that by simply providing infrastructure or small class sizes did not necessarily change instructional practices, as about half of the classes with flexible seating and about half of the small and medium-sized courses were classified as didactic. Okay? All right, I'm going to hit you with another definition because we're going to introduce a new term. So I've already introduced the term student-centered. Now you will also hear the term in conjunction with student-centered, the term active learning. And this term is one that is often confused in the literature. It's widely used and not widely defined. And so it's often something that I struggle with in the education research literature, but I'm going to just show you how I sort of conceptualize it here. Active learning is a broad and somewhat vague descriptor of learning environments in which students are physically and or cognitively active in constructing their own knowledge. And student-centered instructional methods often lead to active learning by students. And so I want to kind of finish up this section by saying here's somewhat of a conceptual frame to guide the rest of the talk. I want to point out that teaching practices are on a continuum or can be visualized on a continuum from instructor to student centers. This is not dichotomous. It's not like lecture or not lecture. Instructor-centered classrooms often lead to more passive student learning, and student-centered classrooms often lead to more active student learning. I always like to point out here that there might be examples at the extremes of these. So an extreme example of an instructor-centered course, I had a faculty member tell me an anecdote once, and I'm sure it's probably not true. It's probably just a legend in academic circles, about a faculty member who showed up to their lecture class one morning and no students showed up to class. And that faculty member stood up and, all darn it, taught their class. They lectured that day to an empty classroom. Okay, to me, that's a great example of a fully instructor-centered classroom, one in which it does not matter if the students are there or not. Okay, that'd be far in on that scale. I would say probably a student-centered classroom, good examples of that would be like fully student-centered, fully active, might be something like an independent study or even like a research mentorship. Okay. All right, so we're gonna pause to breathe just for 1 second at the end of this first section. And I wanna give you sort of the take-home points that I hope you will take home from this first little section, from the data I've shown. First, instructional methods in post-secondary STEM classrooms have not changed much over the last several decades, and you could argue over the last several centuries. Okay. Instructors largely rely on didactic or instructor-centered methods to teach in post-secondary STEM classrooms. And what instructors do in their classrooms, that should be, is not dichotomous. It's not just lecture versus non-lecture. There's sort of a range of different things that faculty can do. All right, so question number 2 that I want to sort of share some data with you. If we know what faculty are doing in their classrooms, the next question I want to ask and sort of explore with you all is what type of instruction is most effective in post-secondary STEM classrooms? So this is a figure some of you may have seen. It's a classic study. This is data from a meta-analysis of just over 150 studies that compared student learning outcomes in active learning classrooms and traditional lecture approaches. Okay. I will note that active learning in these studies was very broadly defined, but was probably somewhere on the continuum more to the left of instructor-centered, as I defined it earlier. And so what this shows is a density plot of the distribution of failure rates within active learning, which would be sort of the blue distribution there, and lecture classrooms, which is sort of the orange distribution. All right, and what you will see is that the distribution of lecture classrooms tends to have slightly higher rates of students failing the course. And so of the studies examined, 21.8% of students failed a course, and that's sort of the average, in active learning formats, whereas closer to 34% failed the course in a traditional lecture format. The authors also broke this down by subject matter. And so this image shows the same failure rate data broken out by disciplines on the left. You can see the various sort of STEM disciplines they tackled on the left. The first figure shows the number of studies and the effect sizes in standard deviation units for exam scores in the studied course. If you're not familiar with effect sizes, this Hedges G is sort of a corrected effect size. It just means the strength of effect of a particular intervention. In this case, the intervention was active learning versus sort of lecture instruction. And the dot in each of these is the mean value, and the line range there is the 95% confidence interval. Anything on this sort of red dotted line would be a completely neutral effect. It would mean that of the studies collected, there was no difference between active learning and sort of traditional lecture. And so what you see, and I'll just use biology as an example here, is that in biology, there's a 0.25 standard deviation increase in examination scores for active versus lecture-only classrooms. And there's about an 18% decrease in failure rates in active learning classrooms. Now, what I showed with the previous data sort of demonstrates how active learning can increase student learning outcomes. This is a study that came out just very recently and I thought was particularly impactful in today's sort of learning environment when we're thinking about issues of diversity and inclusion. Ellie Theobald conducted a similar meta-analysis to show data that demonstrated the importance of active learning for inclusive instruction and reducing achievement gaps in what a lot of people now are calling peers, and I'll use this term P-E-R-S, peers, or persons excluded because of ethnicity or race. This is in contrast to underrepresented minorities, in which many of these folks are, although they're underrepresented in the field, are no longer underrepresented in the US population. So on this left figure, it shows exam score gaps between more traditional white students and the peer students in passive and active classrooms. And so what you can see is there's a subsequent reduction in the gap between exam scores and active classrooms. And the image on the right shows the reduction in the gap of the percentage of individuals, students passing the course. So there's also a reduction in that gap as well. And so active learning assists various students in being more successful in STEM courses. All right, and this is our last little definition break, because this is the term I'm going to be primarily using for the rest of the talk. I want to define the term evidence-based instructional practices. And I apologize if I use the acronym EBIPS. I might slip and do that more frequently, but when I say EBIP, I mean evidence-based instructional practices. And this is just a broad descriptor of teaching methods that are supported by education research data and have been shown to be effective at promoting the desired student outcomes. These methods are often student-centered and do result in active learning of students. Okay, and there are a range of evidence-based best practices. This is a nice sort of classification scheme by a geoscience education researcher at NC State that shows the utility of these practices, both in sort of how easy they are to implement, so how much pre-class preparation is required, in-class actions are required, and task characterization of various practices here. And then sort of the strength of evidence of how much research has validated these particular methods in promoting student learning. And so he's created this nice sort of rubric of particularly effective evidence-based practices. All right, so that we know that active learning methods work, but the question then becomes is, what are these methods and do faculty actually use them? And if lecture is so prevalent as we've seen, where do we see some sort of differences fall out? And so this is where some of our research comes into play. We have conducted research on faculty and their use of several different evidence-based instructional practices. You'll see a list of those practices on the left. It's not as important that you know what those are. I'd be happy to explain what some of the acronyms are if you're interested. But this data is from a survey at a large Southeastern university, and we wanted to know whether our STEM faculty were even aware of many of the common evidence-based instructional practices. And so this was the entire, basically, Arts and Science College was surveyed. And what we're showing here is faculty awareness of those strategies. And we're doing this through the bars. So what you can look at here is the darker sort of black bars indicate if a particular faculty, or the percentage of faculty that indicated that they were at least familiar with one of these strategies. The sort of darker gray indicates the percentage of faculty that had heard about the strategy but didn't really know much about it. And then the sort of light gray was the percentage of faculty that indicated that they were completely unaware of what the strategy was. Okay? And notice that there's high variability in the strategies. We also asked faculty who at least had reported that they were aware or have heard of a particular strategy if they had used that strategy. So it's one thing to be aware of a particular strategy, but it's another thing to actually be using it in the classroom. And so this figure is data from the same study, which shows those evidence-based practices, and asked whether faculty are currently using those practices. The dark black sort of indicates that. This darker gray that you see very little of is where faculty decided to use a practice, but then decided to discontinue using it because it wasn't working for them. And then the light gray is where they reported they were familiar with it, but they don't use it. All right, and so we asked our faculty also in the sample to explain why they had such limited use of these strategies. And we did receive a diversity of answers, but we got a pretty good list of barriers, things that the faculty perceived prevented them from approaching and using these strategies actively. Here we're showing the frequency of time that the barriers were mentioned in our survey. And then these numbers at the top are sort of the average, we call it a strength rating of how powerful that barrier was to preventing them to using active learning strategies. And so you can see some of the most common barriers are fear that evidence-based practices take too much time to prepare for, that it will take up too much class time, which is a whole other thing we can talk about later if you're interested. That they didn't have enough training, they didn't have the resources to implement, that their students would be resistant to it, there was absolutely no incentives to implement these strategies, that there actually was no evidence to implement these strategies. And then some other things about they were worried that their administrators would resist, or that they felt like they had such a strong researcher identity that they wouldn't teach in any type of way besides just lecture. So you see the most common barriers to use were prep time, class time, and then one that we're particularly interested in, which is training or professional development. All right, so again, to kind of pause, let everybody take a breath for a second and see sort of the take-home message for part 2 here. What type of instruction is most effective in post-secondary STEM classrooms? Well, I'm going to use this vague term, active learning methods, but those work best to promote student learning for many student groups, including those that are often underrepresented in the sciences. These active learning methods include a range of evidence-based instructional strategies that can be used. And there are numerous real and perceived barriers that explain why STEM faculty might not implement these practices. And so now that we've identified the barriers to faculty implementation of evidence-based instructional practices, most of our work looks to support faculty and reduce some of these barriers to implementation. And with many of the barriers being related to perceived lack of training and resources, as well as perceived lack of time once in a faculty position, we argue that targeting graduate students as ripe recipients of teaching professional development might be particularly fruitful in reducing some of these barriers for future faculty. So why do we focus on graduate teaching, professional development, and graduate students in general? Well, there are numerous STEM graduate students in the United States, and these numbers are only rising. In addition to the increased number of graduate students, it really hasn't kept up with the education research into the best practices in teaching professional development, as well as understanding the unique teaching perceptions of graduate students. It's really only been since the 1950s that academic administrators began having conversations about graduate students' role in instruction. And it wasn't even until the 1980s when universities began to employ teaching assistants in more independent teaching roles and undergraduate students began to critique the quality of their education, that institutions formally responded with policy initiatives to train graduate students in instruction. There were several conferences in the late 80s and early 90s to address these issues. But as you can see here, much of the research into STEM graduate student teaching professional development did not really take off until the mid-90s. So in addition, we recognize the important role that graduate students play in the instruction of undergraduate STEM students. So for example, there's a lot of research here that I'm gonna present some statistics for, that 85 to 95% of STEM graduate students will have some type of undergraduate instructional role at some point in their graduate careers. More than 80% of STEM graduate students wish to go into academic faculty positions with a teaching component. And 46% of STEM graduate students are teaching undergraduates within 5 years of their own graduation. So to just push it away and to say that graduate students don't really have a role in quality undergraduate education is really not aligned with the data. And so in addition, GTAs have an extremely diverse instructional roles and that might differentially impact students in gateway courses. This is some data from a research study with a cohort of STEM dissertators. It was around 3,000 doctoral students in the study from 3 research universities. And this shows the percent of the sample who participated in various teaching roles during their doctoral careers. What you'll notice is that close to almost 90% served as a teaching assistant at some point during their doctoral career. And these instructional roles are often in gatekeeper courses, especially in the laboratory sciences, chemistry, physics, biology, such that the undergraduates or that the graduate students would have a large impact on early undergraduate student retention. Now, despite this large role that GTAs play in undergraduate instruction, they are rarely provided with effective or sustained professional development. This is data from 52 biology departments in the US, and note that it's just biology departments, not across STEM. And it shows sort of the very limited types of professional development that GTAs received. The most common is mandatory professional, or the most common mandatory professional development is a pre-semester course orientation. So let me sort of orient you to that. These are the types of sort of classifications of professional development that a graduate student might receive. The percent of the sample reported either whether that PD was mandatory or unmandatory, so optional for students in sort of the peach color here. And so the most common is mandatory PD is a pre-semester course orientation or a departmental or institutional orientation or lab prep meetings. These groups of professional development are often not focused, they're not in-depth, and they're not sustained TPD for graduate students. And there's also research that clearly demonstrates that these graduate students following these professional development feel very ill-prepared to teach. And so usually when I present this data, to whether it's to folks who are open-minded enough to sort of have a discussion or to my own faculty in my department, one of the most common arguments I get is that if we engage graduate students in professional development for their teaching, it will take away from their research time. And we are starting to learn through pretty good education research that this argument doesn't hold up very well. And so I'm going to show you some data that challenges some of those ideas. This is actually not my data, but one of my colleagues who's at Portland State. Let me take a sip of water here. This is data where she had STEM graduate students engage in professional development related to evidence-based instructional practices and sort of measured their engagement with that PD to other variables related to research. And so this first graph, and don't worry so much about what the graph is showing, I'm just going to give you the take-home message here, is that teaching professional development increases graduate students' sense of well-being as researchers. It increases their confidence and their ability to communicate research. And it had absolutely no impact on the number of publications produced during their graduate school tenure. This is some data that we've collected recently with my doctoral student, Josh Reed. He got very interested in this idea of how graduate students sort of perceive both their research role and their teaching role. And one of the things that he asked to a nationally representative sample of over 400 biology graduate students was, do you think that research and teaching are in conflict? So what would be called sort of antagonistic, as he labeled it. Or do you think that research and teaching are synergistic, sort of self-supporting? And what we found is that for most of that sample, over 80% of our sample, perceived that research and teaching were at least slightly synergistic, with many of them saying that they thought research and teaching were very synergistic. And in addition, we also asked sort of what their identity was as a graduate student. So we asked them whether they had sort of a teacher identity, some type of mixed identity with teacher at the forefront or researcher at the forefront, or they had a strong researcher identity. And we found that even if they held a strong researcher identity, it did not overly affect how they perceived research and teaching as synergistic. So there was no sort of statistical difference between their perceptions of research and teaching being highly synergistic. And so these are box plots of sort of those scores. So also, in addition to sort of graduate students' perceptions of the research-teaching nexus, how those things overlap, we've also looked at sort of the support networks that graduate students have to support both their research and teaching. And so let me walk you through this somewhat complicated bit of data. And this is only a few of the social networks that we put together with our sample. So what you can see here is a social network. If you're not familiar, each of these nodes, which is the sort of circle here, represents a person. Each of the lines represents a communication that that person had, either about research or teaching. They're color-coded here to represent whether it was a graduate student, a fellow graduate student, a faculty member, an undergraduate student, or an other, like a family member or something. And here, this is a research network. So this is a network of individuals that a graduate student would talk to about research. And this is a network of individuals that a graduate student would talk to about teaching. And I'm not going to belabor you with a lot of the data here, but I want to tell you that one of the most interesting findings that we're really continuing to explore is that at teaching-focused universities, the graduate students have more what we call multiplex ties. And these are ties in which they talk to a person about both teaching and research. Okay. So let me let that sink in real quick. At teaching institutions, so more non-R1 institutions, we have graduate students that are talking more to certain people about both teaching and research. In fact, on average, an individual has a multiplex tie, so individuals that they talk to about both teaching and research, of about 33. So they're talking about 33 other people about both teaching and research. Whereas at R1 universities, that number is right around 6 individuals. Okay? And that these research networks are much more dense at research-focused universities as well. And we're still trying to figure out exactly what that means and how we can leverage that to assist in professional development. All right. I do want to show you this last little bit of data. This is some additional work I've done with large samples of STEM graduate students, thinking about their instructional beliefs. And so one of the challenges that we also have is thinking about what graduate students think about research and teaching. There's a nice interview protocol that has 7 questions, and so that's what you're seeing on the left here is questions 1, 2, 3, 4, 5, 6, 7. It has a coding matrix that allows us to code the participant responses as either reform-oriented, responsive, transitional, instructive, or traditional. Don't worry so much about that terminology. I will draw you back to sort of that scale again. And what you can see here is that when participants responded, these are the number of participants that responded. If this bar is lighter, it means that they tend to have responses more on the sort of student-centered side of the scale. And the darker this bar is, meant the responses are more on the traditional side of the scale. Okay? So that's just sort of an easy way to look at this holistic data. But what I want to point you to is a set of interview questions, which was 1, 3, 6, and 7, that were specifically about their own teaching beliefs. And if you look at their teaching beliefs, what you will notice is that in general, they're much more lightly colored, which tends to indicate to us that graduate students at this level have really more student-centered instructional beliefs. And so to wrap up here, sort of towards the end, we are currently working with a project called BioTap. This is an NSF-sponsored research coordination network. We have really been pushing to try to increase the rigor and the amount, frankly, of research that supports evidence-based best practices for graduate student teaching professional development. Our goals for the project are shown here. We wish to expand and support collaborations with all stakeholders in graduate teaching assistant, teaching professional development, whether you're a facilitator, a researcher. We have completed several research development sessions where we help stakeholders who are not education researchers have the capacity to complete a research project. And then we also have the goal of synthesizing and disseminating and advocating for research to really identify best practices in teaching professional development. So my third part, sort of take-home messages that I want to leave you with, is that STEM graduate students play a large and critical role in the instruction of undergraduate STEM students. STEM graduate students rarely receive consistent or sustained teaching professional development. And this is despite the fact that STEM graduate students really have largely reform-oriented beliefs, perceptions that research and teaching are somewhat synergistic, and often have very strong interconnected support networks. Okay? So they really are ripe for understanding and learning how to be effective instructors before they run into some of those barriers they might run into as faculty. All right, I think I have talked enough. So I'm actually going to end my slideshow and stop share, and I'll pull it back up if we need to, but I would like to I enjoy seeing people's faces while I answer questions as well. So, I mean, you guys don't have to put your cameras on, but for those that want to, can.
Or just a couple clarification questions here. So Mary wanted to know the Kevin Egan paper, which I'm going to put in here. I think this is the right one, Grant.
Yep.
She wanted to know if that data was based on 2 or 4 year, I think, colleges.
That's a good question. I honestly don't know off the top of my head what the sample came from. If you go to the UCLA HERI Institute, the HERI, the Higher Ed Research Institute, they have a bunch of white papers and you can access all their data there. So I honestly don't know the answer to that question though.
Okay. And then there was just a clarification. I knew most of those acronyms, but I did not know SCALE. But I put in POGLE, peer-led, and just make sure those are right there. It's peer-led teaching, learning, and then just in time, but what's SCALE?
So scale-up classrooms are I'm trying to remember what the actual acronym means, but I can describe to you what they are. It came out of Robert Buechner, who's a physics education researcher at NC State, designed classroom spaces that were sort of conducive to student active learning. So they have sort of small group tables, active technology at those tables, and they're working on sort of group work and problem solving related to physics. It's the way that Dr. Buechner talks about it is very much the structure of the classroom is what drives the ability of students to learn better, as opposed to sort of a traditional lecture classroom where everybody's sitting in rows and not able to talk to each other. So that's really how he's marketed scale-up classrooms. But yeah. Oh, see Penny put yeah, there you go.
I'm putting links up as I found the HERI at UCLA, so that's for anyone interested in that. And
awesome.
Then we have a question from Jeff. He says, based on the observations of social networks at research versus teaching universities, do you think it's important to strengthen ties between those types of institutions? If so, what's the best way to do that?
So that's a really good question. And what we did when we collected that data, so that's actually, for this particular study, we went to an R1 university and we went to sort of an R3, I think is I think they've changed those classifications now, but more of a, what's the term now? research but minimal doctoral granting institutions. There's some new Carnegie classification for it now. Anyway, but we looked at within those universities, who do people reach out to? We didn't actually ask to see if people were making connections across universities, but I think that would be important for people to sort of understand the opportunities to build collaborations. One of the things that we're actually really interested in doing is looking at networks through systems like Twitter and understanding how conversations are happening through things like, I don't know how many Twitter people there are out here. I'm relatively new to the format myself. I'm sort of a new school tech person, but you can really easily pull that data off on things like Academic Chatter and other sources to see how people are having those conversations across universities and classify things that way.
Right. And we have a question from Maria. She's speaking specifically to UAB. She says, isn't it required that UAB require graduate students to have teaching training? But why don't you just speak to, in general, how that's working across universities, TA training?
Yeah. So the research I cited from Beth Schuessler, who is one of our co-PIs, the data I showed was 52 institutions. So, obviously it was, I would say, representative, but not fully generalizable. But it does seem like there's a very limited required teaching professional development in general across higher ed institutions. The sort of irony that I see is that a lot of R1 type universities actually have more supports in place through things like the CERTL network. I'm not sure if everybody is familiar with that. I'm throwing so many acronyms at you here. But it's basically a network of institutions that help support sort of holistic professional development of graduate students. So it includes teaching, but also sort of research and other scholarship. And as far as the required versus not required, I don't know really how to answer that, but to say that R1 universities that we tend to think might diminish a graduate student's willingness to go and train to be a teacher actually tend to have the most supports and the most opportunities for those things. Through our BioTap network, we've worked with a lot of faculties and also facilitators of teaching professional development at smaller universities. And you would think it'd be easier to sort of, for our participants to act as change agents and actually go in and say, hey, look, I want to do a research project to sort of evaluate my professional development program and demonstrate that it's particularly effective. And we found that convincing deans and department chairs is a lot harder at those institutions. And we don't know why. That's actually sort of the next grant we're thinking about writing, is to try to figure out how that works and how we can facilitate change more effectively.
Grant, that really ties into my question. We've talked about this many times before, how I always say there's like one job in America where you're not trained for half your job, and that's higher education teachers. No one probably in this room went through a full training program the way you and I did, that focused on teaching and being a biologist. And so I'm curious, because you showed in your data that graduate students are showing that they're interested in student-centered teaching. What is happening between that obvious intent and then first job, tenure track job?
I mean, again, there's so many barriers, and what, we try to, my argument has always been catch them while they're young, right? While they're graduate students, where they have perhaps not become as cynical to the system. And when they transition to faculty positions or any other position, frankly, whether it's at a primarily teaching university, which is where a lot of STEM graduate students actually end up, the data shows, not all of them are going to R1s, that there's just not enough time. Time is always that barrier that really comes up and is the sort of biggest wall that it's thrown up for us and for faculty to really engage in a good discussion about teaching. We've tried to, at MTSU, at least maximize the way that faculty are thinking about it by giving them opportunities that are sort of smaller, quick opportunities, but that are sustained over like an entire year. And those have been relatively successful.
Yeah. So we have a question from Sarah, who is one of Jeff's PhD students. She's saying 400 graduate students is a great number. How do you maximize graduate student participation across universities and even by undergrads in their own university doing online surveys?
Yeah, that's a great methodological question, and one that never has an easy answer. So for Josh's work, which is where the grad student sample that you're referencing, we find that we usually get small incentives. So he offered, I think it was a $50 gift card to like Target or something, and he offered like 10 to 15 of them in a random drawing for those who chose to participate. So that was sort of the first wave of recruitment efforts that he made. The other was just utilizing our social networks really actively, and you can do that productively. Josh in particular is very well connected in the grad student community. He serves a lot of leadership positions through societies, and was really able to leverage that to get some responses. I think the fact that he was a graduate student as well probably helped encourage other graduate students to participate.
Yeah, networking is super important. Erin Richards had a comment. She said there's very little consideration for teaching and getting tenure, and then junior faculty are encouraged to have less focus or a laser focus on their research at the University of Kentucky. But I think, Erin, you're not alone. That's very common. But then Cindy has a question, and anyone chime in if you want in the chat box and offer some advice, is asking, any thoughts on evidence-based teaching for online teaching, which seems like a lot of us are experiencing right now. So I'll throw that to Grant, but if anyone has any thoughts about that, let her know in the chat box.
Yeah, I mean, I can address, at least anecdotally, those two comments. I mean, yes, I would say anecdotally, with conversations I've had in general, traditional tenure track positions have focused more on research. Now, there are some sort of like PUIs, which are primarily undergraduate institutions in which your tenure is fully determined by your instruction, and even then, sometimes not always. It is true. I don't think there's a magic way to solve that issue. I would like to think, and so my anecdote here is that even MTSU, which is traditionally, it started as a normal school, which was training teachers, still has a pretty strong instructional identity in that our president and most of our departments still preach that undergraduate instruction is our primary goal here. I still only had to hand in student, our SOIS, our sort of student survey that they give at the end of the semester. And that's largely what determined my teaching part of my tenure. So there's one anecdote. So to Cindy's question, I think that we actually have to readjust our thinking about how we teach online. But I would argue that most of those sort of methods, those evidence-based instructional methods that I listed, transfer online pretty easily. I mean, everything from group work in breakout rooms on Zoom to posting questions in which students can respond in the chat. There are ways to tweak what we might do in person to online formats. And I will share this anecdote. I actually had a faculty member who came to me the other day, and it was fascinating. So he has taught online, shifted to teaching online in one of his undergraduate courses, and said, so what I've started doing is just putting my PowerPoint sort of lectures online. I let my students look at them and kind of learn the material, and then I hop on to Zoom and we just talk about stuff. Like, they ask me questions, I engage them in deeper thinking about the material. And he's like, that's awesome. He's like, I'm never going back. Like, I'm gonna, when I go back to in person, just give them the slides offline and then have them come to class and engage in productive discussions in class. And I was rah, 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 I'm so excited for you, that's awesome. But in my mind, I'm going, well, you just discovered basically flipped classroom instruction for yourself, the efficacy of flipped classroom instruction. And so I think this opportunity that we have with online instruction might actually be one that is incredibly unique to provide sort of teachable moments for faculty and perhaps graduate students even on how to productively engage in evidence-based practices. Yeah, I see Jeff Moore has posted a similar comment that I just made. Yeah, posting asynchronous lectures, yeah, it's freed you up to do more actual active type engagement. Cool.
I'll just chime in too and add that I think we do a lot of assessment when we're in person, that can also be really effective to holding students socially accountable to the material. So formative assessment, which is, small assessments along the way that provide instant feedback to students, is a great way to use evidence-based teaching online. So a lot of times we get focused on more summative assessment, these big exams on even something like Canvas or D2L, but those small assessments along the way. And, I'm finding that when it comes to motivation, you have to incentivize the task, right? They have to value the task. Even something simple as, I want you to read this abstract from a scientific paper. If I don't then attach a one question quiz to it, they won't do it, right? There has to be some value. So attaching value to everything you're posting online can be helpful in incentivizing students to do whatever it is you want them to do, like draw, think, write sentences, summarize a lecture with a few sentences, etc.
And I would challenge all of you to as someone who's conducted a bunch of professional development, both with faculty and with K-12 instructors, is I often hear when challenging times arise that when I'm engaging in a conversation with folks I'm working with, is that I hear, I can't do this. Like, it's too hard to do this. We can't do this because. And my response has always been, when I hear myself say that in my own classes, is that's a challenge. I'm a very competitive person. That's a productive challenge to me. Like, if you can't do it, or if someone tells me I can't do it, I'm going to figure out a way to do it. And that's sort of how I feel now in this time of online teaching, is there's so many things being thrown at me that seem sort of like impossible tasks or big barriers to effective instruction online. And that just sort of, I challenge all of you all to think about how to use that as productive conflict and really use it as a time to reflect on how you can make your instruction better. Yeah, I see Mary Phillips asked, I know we're getting close to time here, but I'm exploring transparency in teaching and equitable courses and assessment. I'd be very interested in learning more. Mary, I would be too. We're actually currently engaging in a college-wide professional development that I'm helping facilitate, related to sort of equitable instruction and inclusive teaching, and I'm hoping to learn a ton. I can't claim that I'm an expert right now on that at all. And doing that online, there's probably all sorts of other additional challenges.